All right, welcome to class. It's Monday. Hopefully everything's going well. Make sure that you are taking care of yourself. You should know the rules. Asking to go to the bathroom when I have a sub, don't forget that. Make sure that your phones are put away. These are just quick recap. I know we talked about it on Friday, but it's something that you need to remember. Again, no arguing. Have a great day. Should be pretty easy to finish up your classwork in class. If not, you'll take the half sheet worksheet home, finish it, and we will go over those on Wednesday upon my return. So I am going to clear out the screen. When I clear out the screen, you will do your warm up. Take care of business today. Do your best. And I will see you guys Wednesday, but you will hear from me again tomorrow. You can pause the video now. All right, welcome back. Hopefully you finished your warm-up. The majority of us are going to do this warm-up a little crazy, and that's because we're machines, and machines do. So if I were a betting man, my next line for what you guys would be completing is probably just like a book. Remember that you have to show me work. So my guess would be that you have this written down some way. You are smart enough to know that I require all of your work. You took 35, you added 8, and added the 7. So the only thing that you completed right off the bat was just compiling 12 and 23 together, and 12 plus 23 gives you your 35. Okay, that's if you showed me as much work as I was requiring. Hopefully that's where we have some work. If you don't have work, then we need to make sure we're showing work. So that would be my guess is where most of you started. From there, if you did that style of work, you then added 35 and the 8. When you added the 35 and the 8, you were at 43, not 73, I apologize, hit the wrong button, 43, and then you added the 7 to it. And then your last number then is hopefully 50. Now, if you went in a different pattern, hopefully you can identify what that pattern was. Again, for us, 12 and 23 is 35, and then if we added the 35 and the 8, we get the 43, and then 43 and 7 is 50. Not the only way to do it, but that would be my guess. If you didn't do it that way, then there is a good chance that your math might be something a little bit more like this. If you started out with the 12 and 23 again, because a lot of students are going to do that, you get your 35. But then as we get better at math, you start adding in the other values. So you might add at the exact same time the 8 and the 7, which is fine as long as you have the work that goes with it. 8 and 7 is 15, 12 and 23 is 35, and then when you combine those values, you get right back to 50. Again, I just need to see your work. Today we are going to be focusing on number properties. Hopefully the warm-up went well. Realistically, I'm hoping that you somehow came up with that guy. If you didn't come up with that guy, you need to double check your math. Okay, find where your mistake happened. If you can't find it, ask Mrs. Ortman, ask the sub, or ask me when I get back. Now, I'm going to change this up a little bit. And the reason that I'm changing this up a little bit is as we go farther in math, we want to work smarter. Remember how I tell you guys not to be machines? Think first, then do. If you think first, you would recognize, same problem, that with adding, I can move things around. Some of these numbers are going to add nicer with one another. 12 and 23, we might not know 12 plus 23 off the top of our head. Because we don't know 12 plus 23 right off the top of our head, maybe we move some things around. So I changed my order. Instead of adding 12 plus 23 plus 8 plus 7, I went, I know what 12 and 8 is. Those are easy numbers to combine. In that same fashion, I know 23 and 7 are easy numbers to combine, and that's because I know 3 plus 7 really fast off the top of my head. By doing that, I can create two really easy numbers. I apologize, I highlighted completely backwards. We should have gone yellow first. 12 plus 8, and then the blue. I think I'd have this stuff memorized. And that was only because I'd already pre-highlighted. 12 and 8, 20, 23 and 7, 30. So those numbers are also easier to add. Notice when we went back to the last page, 35 and 15, that number doesn't just jump out at you. 2 plus 3 is 5. It jumps out to give you 50 really quick. So today's lesson is really focusing on what we just did, our ability when we are adding to change the order. This is a big problem, but really if we focused on small numbers, we could have easily come up with this just by looking at 2 plus 3. 2 plus 3, when we compare that to 3 plus 2, we would find that those two values are the same. They both give you 5. So 2 plus 3 and 3 plus 2 are considered equal. So easy numbers help us to solve some math really, really fast. So if you're a student that wants to learn the properties really quick, 2 and 3 are going to be the numbers you're going to want to choose to see if it works. So today's lesson, again, we're using number properties and we are using them correctly. First thing, we need to be able to identify when a statement is true. So in this case, if I'm looking at this 4 and 3 more, 4 and 3 more is going to give me 7. On the opposite side of that then, I'm going to have 2 and 5 more. I also get 7. That statement is considered true. You'll see a lot of time that people make an image, and that image is like a scale. It's got one side, the other side, and basically when those two sides are balanced, it's going to be flat going across the top. True statements, scale is going to be balanced. That's where that image is going to show up a lot. 7 is equal to 7. That is a true statement. Versus, if I look at 4 plus 3, 4 plus 3 gives me that 7 value again. 7 plus 3 gives me 10. Now notice the 10 is farther down than the 4 plus 3 is 7, which if you think about weight, 10 would outweigh 7. That's why it's all the way down here. It tips the scale. The scale is no longer equal. When something is not equal, you don't have to write out every time that it's not equal. I want us to be using proper conventions, and our proper conventions are simply this. You take your equal sign and you make it to where it is not equal. You just put a line through it. It needs to be at a slash. This is the proper way to write it. And when we write that symbol, what it tells anybody that is math bound, not equal, is simply stating that it is not equal to. So I need you to remember that symbol. You're putting it somewhere in your notebook. Equal sign, slash through it, and then you're writing next to it is not equal to. This is a big deal. Don't ever tell me any other fashion other than this symbol. That's what I'm hoping for. Proper conventions. So we have a true statement where the scale is balanced. That's the picture. True statement is just that the same number is equal to the same number. Remember that it doesn't always have to be numbers, but in this case we're talking about numbers. So 7 is equal to 7. 7 does not equal 10. So you would write it as 7 does not equal 10. I apologize for my bad handwriting. I'm writing on the computer. So next, you are going to add the following into your notebook. As we go through this, each of them need to be written down. It's going into your notebook. Your notebook should already be out because you did the warm-up. So we're adding these into the notebook. You are going to copy the problem. After you copy the problem, you are then going to state if the statement that is there is true or if it is false. That is your job. So we're going true or false. Statement number 1, copied into your notebook. This is number 1. It is going into your notebook. So 8 plus 0 equals 8. You are then stating whether or not that statement is true or false. Not T and F. You're writing down true, T-R-U-E, or false. So make sure you write it, true or false. I don't want anybody telling me that it's this guy. Got it? It's true. No, that one's false. Don't give me the symbol. Write true or false. Number 2, you're adding this again to your notebook. You have 240 plus 0, or excuse me, 224 plus 0 equals 240. So 24 plus 0 equals 240. You're putting that one into your notebook, writing down whether or not you think that it is true or false. Number 3, you're copying into your notebook. 5 times 3 equals 3 times 5. Again, make sure you're writing out true or false. Next problem, number 4. A times 2 equals 2A. Number 5. 5 plus 1 equals 1 plus 5. Number 6. 3 minus 2 equals 2 minus 3. So again, these need to be organized in your notebook. Said it over 3 times now. We will come back to these when I return. And lastly, number 7, 8 divided by 2 equals 2 divided by 8. Again, you're telling me whether or not these statements are true or false. That is your job, true or false. So the last one was 8 divided by 2 equals 2 divided by 8. So true or false, that's what we're looking at. True or false? You should have all of those written in your notebook somewhere where you can find them. Number 1. As we look at number 1, so I'm going to cover this back up. Number 1, we had 8 plus 0 equals 8. Hopefully you came to the conclusion that this is true. If you don't have true written down and you have false, don't erase it. Put a line through it, change it to true. 240 is equal to 24 plus 4, or 24 plus 0. This is false. That one is a false statement. 24 plus 0 is just 24. If that one would have been true, then this previous problem would have made no sense. So, number 2, false. Number 3. 5 times 3 equals 3 times 5. Hopefully you came up with the fact that that one is true. So number 3 should be true. Number 4. A times 2 is equal to 2A. Well, our proper conventions tells us that this is actually the appropriate way to write A times 2. A times 2 should be written as 2A. So that means that this statement is true. We're going to change that bad boy's color. False is bad. We don't want to be false. We want to be true. Sound good? So, number 1 is true, 2 is false, 3 is true, 4 is true. Number 5, 1 plus 5 and 5 plus 1. That statement is true. Number 6, 3 minus 2 and 2 minus 3. Now you might actually want to show some work for this. If I had 3 minus 2 and 2 minus 3, 3 minus 2 is going to give me 1. 2 minus 3 is going to give me negative 1. Does 1 equal negative 1? No. That means that statement is also false. 1 does not equal negative 1. And then your last one, 8 divided by 2 and 2 divided by 8. 8 divided by 2 is 4. So if you were actually doing the math here, we get 4. 2 divided by 8 is 0.25. Easy problems lead to easy mistakes. Hopefully we could see that those two are also not equal. 4 does not equal 0.25, so that last one is also false. So your answers 1 through 7, you should have had true for number 1, false for number 2, true for number 3, true for number 4, true for number 5, false for number 6, and false for number 7. Okay, those values are going to be similar when we look at something that's a little bit bigger. So when I say those values, those rules, those properties that we're starting to recognize are going to be the same. So notice if I took 2 plus 3 plus 4 and I ask myself, and that's really what's happening here, we're trying to see if this is true. So we're saying, does this equal 2 plus 3, or 2 plus the quantity of 3 plus 4. So you'd first combine the 2 and the 3, that's 5. You'd first combine the 3 and the 4, that's 7. 5 and 4 is 9, and 7 is 2 is 9. So that is a true statement. So when we are adding, it is true. So that was when we added. So I'll put over here A-A-D. There it is. Add. Adding is true. So no matter where I put my parentheses, as long as everything is adding, it's going to give me the same answer. If I am using subtraction, subtraction winds up being false. 2 minus 3 is negative 1. 3 minus 4 is negative 1. So far so good. But then the next values kind of throw some things off. Notice I still have the same pattern. 2, 3, 4, 2, 3, 4. I'm just subtracting now instead of adding. Negative 1 minus 4 more is negative 5. 2 minus a negative 1 is 3. Those are not equal, so that is false. So it does not work for subtraction. It does not work for subtraction. So subtracting is false. Do not use subtraction rules of being able to move things around. You can't just change the parentheses whenever you want. Hopefully you understood that. Looking at the next. Oh, we'll go this way. 2 times 3 times 4, so 2, 3, 4, and then again 2, 3, 4. If I'm multiplying 2 times 3 times 4, does that equal 2 times the quantity of 3 times 4? 2 times 3, 6, 3 times 4, 12. 6 times 4 is 24. 2 times 12 is 24. So that's a true statement. It looks like it's going to work for multiplying. What about division? If we add in division, division does not. Now they might be close. That's just because of the numbers that we chose. Division does not work to change up our order just by adding in parentheses. This is really, really important. So your associative property that we're going to talk about, moving the parentheses does not work for division. Moving the parentheses does not work for subtraction. Sound good? This is a big deal moving forward. Adding and multiplying, yes, which kind of makes sense because if it works for adding, multiplying is a fancy way to add. So it makes sense that those two work. Here are your properties. These are the properties that you just used without probably even knowing. Realistically, the properties that we were focused on the last slide were right here. It's the associative property of addition. That's where we were at. A plus B, the quantity of A plus B plus C is equal to A plus the quantity of B plus C. That's the one that we just used. You guys used a lot of these properties all day. The identity property of addition. If you add 0 to a number, it stays that exact same number. These you need to know. So we'll go through them. The identity property, identity. When you're looking at an identity, you're talking about what that number identifies as. A is A. That's what it is. So what can I add to anything that will keep it the exact same? Well, 0. So the identity property is adding 0. This is for addition. Notice you also have an identity property for multiplying. If I have an A and I want to multiply it by something and still keep an A, the only thing in the world I can multiply by is 1. You have to be able to use addition when you're talking about identity of addition. You have to write down multiplication if you're talking about multiplication. These are two different properties. One's for adding, one's for multiplying. Commutative. When you're working on the commutative property, the commutative property is going from A to B or B to A. A plus B is exactly the same as B plus A. We did this on some of our stuff. This one kind of makes sense to us. 3 plus 2 is the same as 2 plus 3. The same thing is going to be true for multiplication. When I multiply A times B, so some number times another number, A times B, 3 times 2, that's exactly the same as 2 times 3. So we can change the order. So the commutative property allows you to change the order. It is only true for adding and multiplying. Changing the order did not work for division or subtraction. So you can't just randomly change orders up. That one was the associative property that we just did prior. The associative property then, it's who you associate with. So if you notice, I always think about the two parentheses. You got your arms around your buddies, however you want to look at it. The A is associating with the B here. On the other side, the B is associating with the C. When we have the associative property, we're choosing to add in parentheses to make the numbers work out better. So what we're hoping there is that B and C might be easier to add. So instead of adding A and B first, we use the associative property to say, now I'm going to add the B and C first. I'm going to add parentheses over here. And this is how we rewrite the problem. It is equal. The associative property of addition is equal. So you can associate with addition Similarly with multiplying. So if you use easy numbers, 2 times 3 times 4, again, if you use easy numbers, who you associate with sometimes might be easier to multiply one way than the other. For example, 2 times 3 might be easier for you to multiply to get 6. If you didn't like it that way, then you would know the associative property and you might go, nah, I know 3 times 4 is 12, and 12 times 2 is 24. It'll take you back to the same answer. That's the associative property. And then the last one, we should all know by now, anytime that you multiply by 0, you get 0. That is the 0 property of multiplication. Okay, today's stuff. You need to finish this before I return. We are trying to finish this in class today. I won't grade it until I come back. You need to try to finish this. I'm going to leave this page up. You will get a worksheet. You need to finish that worksheet. If you do not finish the worksheet, then it goes home and becomes homework. Your homework is as follows. Classwork 1.6 worksheet. Make sure it goes into your notebook. Copy everything into your notebook and have a great day.